Day 8, solving rational equations. What we've been doing the last couple of days is like finding the LCD and making sure that both of the fractions match is basically what we're doing today. We're just adding and solving. How do we know when we're solving and whether we're just adding and subtracting? Nope. If we're solving something, what do we have?
An equal.
We have an equal sign, so that's how we know what we're doing in this lesson. First, you want to get all fractions that have the same common denominator. Alright, so just like adding and subtracting, you give the fractions the factors they are missing on the top and the bottom. Step 2 is to cross out the denominator. Step 3 is to solve for x. And then we want to check for extraneous solutions. The way we check for extraneous solutions is by plugging it into the LCD. Okay? When you do that, if it equals 0, then it is an extraneous solution. And you can just abbreviate it just like that, EXT. We would do that for every single problem. Do we have these words down? Isaac, do you have these down?
Yes, I'm on that. Okay.
Alright, let's look at number 1. What I want you guys to look at is I want you to notice that we have a denominator before the equal sign and a denominator after the equal sign. Are they both the same? Yes. So this would basically be my LCD. Okay, if they're both the same, my LCD is x minus 3. Once we get our LCD, we cross out. You cross out your denominator. Once you do that, we're just basically taking what's on top and we're going to solve it. So x is equal to 6. Is there anything to solve here?
No.
There's nothing to solve, so that's just my answer.
Oh, this is easy.
Well, this is only the first one.
Oh.
None of them are this easy. Okay, so what you have to do, and don't forget this, Kenny, my LCD was what? Okay, so x minus 3 was my LCD. Just write this on the side somewhere. What did I get for my answer? 6. So I'm plugging in 6 for x. What is 6 minus 3? 3. Is my answer 0? No. So therefore, this is a solution. That's what I'm looking for. When I plug in my x, I'm looking to see if I have a number higher than 0. Because if it is 0, we have to write EXT for extraneous. Do not forget this part. Okay, it's part of your answer. You guys have to remember to check it. On your test, I actually bolded it. Make sure you check for extraneous solutions. But that requires you guys to read your directions. Okay? So number 2. Do I have the same denominator?
Yes.
Yep. So I'm going to just cancel out my denominators. Once I have the same, I'm going to cancel out. And then I'm going to add what is on top. So I have x plus 5 is equal to 5. I'm just rewriting my numerators. How do I solve for x here?
Minus 5.
So let's subtract 5 from both sides. My 5's cancel out in the beginning, so x equals 0. 5 minus 5 is 0. We're almost done. I have to check my answer. My LCD was x, right? But what do we get from my answer? 0. So 0, 0, right? This will be extraneous. So So all you have to write is EXT. That means that we did all the work right, but my answer just does not work.
And how many of those are gonna be on the test?
Well, I don't know that. I haven't done my answer key yet, but as long as you check. So it's basically going to be like a mix of all these problems, right? Like it's going to be 4 pages for test 1 and then 4 pages for test 2. But since we cut out that test 1, I had to combine them. It doesn't mean your test is now 8 pages, but there will be a good mix of all these problems.
Last time you said no solution on all of them.
Yeah, because you guys wrote no solution on all of them.
I always say
Or that was prime.
the rule of thumb is 1 to 2. She's never going to give you a test with more than 2 times on it.
No.
She's never going to give you a test with more than 2 extraneous solutions. She's never going to give you a test with more than 2 no solutions. Never going to happen. 1 to 2.
Never. But when they turn in their homework for factory,
Oh, the
everything's
17
prime.
problems.
Yeah.
And that's why this year in Algebra 1 they eliminated. In Algebra 1 you're not allowed to write prime on anything.
Oh, that's sweet.
Yep.
Yeah, they think prime means I don't get it, so. Nope. So yeah, it's not gonna be that many. Those are 2 different problems, right?
Yeah.
So think before apple, oh my goodness. Before equal sign and after the equal sign. What is my LCD for the first fraction? What's my denominator? No, for the first fraction?
Oh, X.
What about for the second fraction? Do I have any pairs? No, so that means I'm going to multiply these together. So what is x times 2?
2x.
Just 2x. What I want you guys to do, don't mess this up, pay attention. You see how we have a fraction is equal to a fraction? Write that again, fraction equal to a fraction. And my LCD is going to be 2x. Now let's think back in our brains to what we did on day 6 and 7. Okay. I have an x in my old denominator that matches my new denominator. What am I missing?
Oh, the 2.
Oh my goodness, you prick. The 2. So I multiply the bottom and the top by 2. 2 times 2 is 4. In my second fraction, I have the 2. What am I missing?
The X.
I'm missing the x. So x times x
X squared.
is x squared. Alright, my top is now complete, so I can cancel out my LCDs. And I am left with 4 is equal to x squared.
Wait, don't you guys do the square root?
We haven't got there yet. We're just rewriting the numerators. Okay, so, actually, yeah, you could do that. If you wanted to dose it, you could minus 4 to both sides, and then you could dose. I like to take the square root. So when I cancel out my square and my square root, I'm left with x equals, what kind of 2? I drew my radicals, and therefore I need to draw what? Plus or minus, don't forget that. If you solve it like Jeffrey just said, 4 equals x squared, and you subtract 4, you have 0 is equal to x squared minus 4, which means this is dose. This also works. Okay, because your x will equal -2 and +2. Does that make sense? Either way works. If you can see that that's the square root, then do that. If you can see that you want to subtract 4 and get everything to one side, do that. But we have to check. My LCD was 2x. So my first x was +2. My second x was -2. Will either of these give me 0 if I multiply? No. I get +4 and -4. So both of these answers work. Put check marks. So far, so good? All right, let's look at number 4. Before we begin, let's make sure that we're all dealing with fractions here. I have 3 over 2, 1 over x, and then 2. How do I change this positive 2 to be a fraction? Yep, let's make it over 1. So what I want you guys to get into a habit of doing, maybe not this.
I have no idea what's happening.
All right. What I want you guys to see is that everything to the left of the equal sign is basically one fraction. Everything to the right of the equal sign is basically one fraction. So when we do our LCD, we should always only have 2 denominators, okay, that we're trying to compare. I have my first one and I have my second one. My first denominator, I have 2 and I have x. So let's write 2 times x. My second denominator is after the equal sign and I have a positive 1. Do I have any pairs here? No. So I'm basically going to multiply them all to each other. So 2 times 1 times x gives me what?
2x.
Your multiplier, remember? Yep, 2x. Okay? What I want you guys to do is to copy what I'm doing. I have a fraction divided by a fraction is equal to a fraction. So write that again. This will help you in the long run. I don't want you guys to combine what's on the left side. So I have 2x, 2x, and 2x. Look at your first fraction of 3 over 2. I have my 2. What am I missing? Out of my LCD, my x. So I'm going to multiply the bottom and the top by 3, or by x. 3 times x, 3x. My middle fraction, I have my x. I am missing the 2. So let's multiply the bottom and the top by 2. So 1 times 2 is 2. Your third fraction, my first denominator was 1. My new LCD is 2x. So what am I missing?
X.
What about the 2?
And 2.
I need to multiply the bottom and the top by 2x. So 2 times 2x
4.
is 4x. Now the top is complete, so what do I do? Cancel out what?
1.
Let's cross out the bottom denominator. Sorry. I hit something. Alright, so now let's rewrite what's on top. I have 3x plus 2 is equal to 4x. And now we can solve. How do I solve this problem?
Minus 3x. Both sides.
Subtract 3x to both sides. And so I'm going to get 2 is equal to 1x. Before I'm done, Jeffrey, what do I need to do?
Oh, no.
Well, if you put 1x, then yeah, you would divide by 1. But let's say we have our answer. What do I need to do before I move on? I need to check it. My LCD was 2x. What did we get for x?
2.
So my answer is 4. Is that a solution or is it extraneous? Put a check.
I'll show you this one.
I'll get on this first page. All right, on the back page, I'm going to go through numbers 5, 6, and 9. Okay, we're not going to go through all of them. One, we don't have the time to do so, but we're going to go through those 3 because they all are very different problems. All right, so let's take a look at this problem, number 5. I have 2 different denominators, one on the left side of the equal sign, one on the right. They are not matching, so I need an LCD. My first denominator is x minus 1. My second denominator is 3x plus 2. Do I have any pairs? No. So that means that everything just comes out separately. 3x plus 2, x minus 1. Alright, from there, we're going to copy what we see. A fraction equals a fraction. Make sure you leave yourself enough space because we have to put our LCD underneath it. You are not allowed to skip this part. I get it's a lot of writing, but you have to do it. So we have a fraction equals to a fraction with our new LCD. All right, take a look at number 5. I have my x minus 1. What do I not have? The 3x plus 2. Keep this in parentheses. Because if you don't, then you don't distribute, which is a part of the problem. So on top, if I want to multiply 3 times 3x, 9x, 3 times 2, on the other side, I have 3x plus 2 for my old denominator. What am I missing? The x minus 1.
On top of the full.
So that, hold on a second. If I distribute, I have 4 times x, which is 4x, and then 4 times negative 1 is negative 4. Eric, what do I do at this point? I have my top and my bottom all complete. Good. I'm going to cross out the bottom. And on top, I'm left with 9x plus 6 is equal to 4x minus 4. Jeffrey, how do I solve this for x? You can do this in many different ways, so how would you do this? How would you solve it for x?
4 minus 4.
Okay, I would do the same. Let's minus 4x. And I'm left with 5x plus 6 is equal to negative 4. Some people move in the positive 6 first. That's perfectly fine. It's a 2-step problem, but we still should end up with the same answer. So then I'm going to minus 6, and I should get
10.
5x is equal to negative 10.
And then x equals negative 2.
When I solve for x, I'm going to divide by 5, which gives me x is negative 2. We are not done yet. We need to check for extraneous solutions. Okay, so some of these LCDs have been pretty easy, but now that we have a longer one, I'm going to show you how to put it into your calculator. So grab your calculator. Okay, and we're basically just taking what we have, 3x plus 2 times x minus 1, and we're going to plug it in. Okay, so we have parentheses 3. Whenever I plug in an x, I put that in parentheses too. So my negative 2 is in parentheses, plus 2. I close out my parentheses. All I'm doing is writing everything that I see. I'm just plugging in negative 2 where I can. Then it has parentheses, and I have an x, so I put negative 2 in parentheses. And then minus 1. And we get 12. Ms. Mitchell, for the store button?
You can't ask me anything about the store button. I never use it, and I don't teach it.
Oh, really?
Nope.
I'll have to play around with it, because I normally don't either until SLOs, but Alright, is my answer 0? No. So this will be a solution. Just put a check mark so I know you checked it. It's all good. Don't be confused and think that your answer has to be 0 for it to be extraneous. That is not true. It is when you plug it back into your LCD, you get 0. Alright, let's go to number 6. What I'm going to do first is I'm going to put everything, I'm going to make everything a fraction. So I have x over 1 plus 6 over x equals negative 5 over 1. If we take a look at my LCD, because we need one, I have my first fraction in front of the equal sign and my second fraction. My denominators before my equal sign are here. 1 times x, do not add them. After the equal sign, we just have 1. What is my LCD going to be if I have to multiply everything together? Well, I have a pair right here, right? So what's my LCD? 1 times x is just 1x.
Oh, x.
Alright, I want you guys to mimic what you see. Stop talking, please. You have a fraction divided by a fraction is equal to a fraction. So I want you guys to write that exactly as you see it. Alright, my LCD is x. If you look at your first fraction, your denominator is 1. What are you missing from 1 to x? X. You're missing the x. So x times x
X squared.
is x squared. My middle fraction, I have x and I have x. Am I missing anything? No. So I keep my 6 the same. I'm not missing anything. My last fraction, I have 1 and I'm going to x. So what am I missing?
X. So we become x.
So I have negative 5 times x, which is negative 5x. Now that I have my whole numerator filled out, I'm going to cancel out what's on the bottom. Once I cancel out, I need to rewrite my numerator. X squared plus 6 is equal to negative 5x. How do I solve for x here?
1 plus x squared.
Be careful. Is x squared the same as x?
No.
No, I don't have any like terms here. So let's just get everything to one side. What side should we get everything to? Like, should I move the x squared to the 6? Should I move the negative 5x? Yeah, let's move that. It's so much easier. I'm going to move the negative 5x. I'm going to add 5x to both sides. And I'm left with x squared plus 5x plus 6 is equal to 0. What does it look like we need to do for this problem? The AM method. Good. I need two numbers that add to give me 5 and multiply to give me 6. Jenny, what do you think we need? Okay, so 1 and 6 is a quadruple that everyone says. It works for multiplying, but if I add it, I get 7. That's not what I need, right? 2 and 3. If I multiply, I get 6. If I add, I get 5. So that's the best one. So let's go ahead and write this in. We have x plus 2 and x plus 3 is equal to 0. Almost done. I need everything to equal 0. I gotta get rid of this equal to 0. So I'm gonna set each factor equal to 0 to get my answer. So if I have x plus 2 equals 0,
X equals negative 2.
and I subtract 2 from each side, I get negative 2. And on the other side, if I subtract 3, I'm left with x is equal to negative 3. what was my LCD in this case? It was just x, right? X is -2, x is -3, or either of these answers 0? No. So because my LCD was just x, I just plugged it in. Nothing really to solve there. I know those are going to work. All right, the last problem we're going to do together is number 9. Before we start number 9, I want you guys to change this minus sign to what? A plus, and what happens to my 1? Yep, you have to take the opposite sign. You cannot just change your minus to a plus without taking the opposite sign of the next number. So, I know I need to find an LCD. My first fraction, I have an LCD of, or denominator of x plus 2 and x. So I'm just going to plug those both in. I have x and I have x plus 2. Put them in parentheses if you want. My LCD for number 2, I need my denominator for the second fraction, which is after the equal sign. Once again, x times x plus 2. Do we have any pairs here?
Yes.
Yes. We have x, and we have x plus 2. So that is going to be my LCD. The important part here is that you guys don't try to find 3 LCDs. You only need 2, before the equal sign and after the equal sign. So we're going to rewrite this as a fraction plus a fraction is equal to a fraction. My LCD is going to be x times x minus 2, x times x minus 2, and x times x minus 2. Yes, you have to write all of that. Do not try to cut corners there. Alright, let's look at your first fraction. We have x plus 2 in my denominator. What am I missing from my new denominator? Oh wait, where did I get... Oh, I wrote this wrong. These should be plus. Make sure you guys have plus here. Okay, so I have x plus 2. What do I not have? The x. So multiply the top and bottom by x. What's x times 2? 2x is my new numerator. For my second fraction, I have x. I'm missing x plus 2. Keep this in parentheses or you will mess up with it.
-2x. I think.
Hold on, please. -1 times x is what? -1x. And then -1 times 2 is -2. We keep it in parentheses so we can see that we have to distribute that -1. Which is also why we changed my minus to a plus and my 1 to a negative, so you can see that you have to distribute. My last fraction, nothing changed, so I keep my -4. Jericho, what happens to my denominator? Oh, well, bottom's gone. So I am left with 2x plus -1x minus 2 is equal to -4. If you don't want to write the plus negative here, you don't have to. You can just make it a negative. Same thing. What's 2 minus 1? It's just 1. So we have 1x minus 2 is equal to -4. And then we're going to add 2. So x is equal to -2. My denominator was x times x plus 2. Well, let's plug it in. My x was -2, right? So -2, then I have -2 plus 2. What's -2 plus 2? 0. What's -2 times 0? 0. So my answer is going to be extraneous.
Yes.